Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 5 to the power of x plus 2 is equal to 4 to the power of x. Now, I obviously want to find the value of x for this. So for my solution, first start with 5 to the power of x plus 2 is equal to 4 to the power of x. Now, I'm going to take the natural log, or also ln, on both sides. So now I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now, an important property of logarithms is that if I have something in the form ln a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times ln a. And what makes this property so important is that, let's say we had 7 to the power of x is equal to 9. Let's say we had this problem. So now, as you can see, x, this is an exponent. And it's going to be really hard to solve for x because we know it's going to be a decimal. Because if you notice, 7 to the power of 1, this is 7, and 7 to the power of 2, this is 49. So the value of x is going to be somewhere in between 1 and 2. So now to find the value of x, at its current state, it is really difficult. However, by using this property, if I take the ln on both sides, I can now move this to the front. So now I have x times ln 7 is equal to ln 9. And now, as you see, x is a normal term, and it is much simpler to solve for x. Now all I have to do is divide both sides by ln 7. These two cancel out, and I'm left with x is equal to ln 9 over ln 7. So that's why this property is so useful. So now for our original problem, I had ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now I can move both these exponents to the front. So now I have x plus 2 times ln 5 is equal to x times ln 4. Now I'm going to go ahead and distribute ln 5 to both these terms. So now I have x times ln 5 plus 2 times ln 5 is equal to x times ln 4. Now I'm going to subtract both sides by x times ln 4, and I'm also going to subtract both sides by 2 times ln 5. I have x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. Now from here I can factor out x, so now I have x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now if I divide both sides by ln 5 minus ln 4, these two cancel out, and I'm left with x is equal to negative 2 ln 5 over ln 5 over 4. So this is my answer. Alright, so I have 2 to the power of 19 minus 2 to the power of 18. So to solve this, 19 here I'm going to replace with 18 plus 1, because 19 is the same thing as 18 plus 1. So now I have 2 to the power of 18 plus 1 minus 2 to the power of 18. Now, if I have something in the form a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So in this case, 2 to the power of 18 plus 1, that's going to equal 2 to the power of 18 times 2 to the power of 1 minus 2 to the power of 18. Now, I'm going to go ahead and factor out 2 to the power of 18 from this. So now I have 2 to the power of 18 times, now 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18 is simply just 2 to the power of 1. Now I have this minus 2 to the power of 18 divided by 2 to the power of 18, simply just 1. Now I have 2 to the power of 18 times, now 2 to the power of 1, that's the same thing as 2, so I have 2 minus 1. So now 2 minus 1, that's simply equal to 1. So now I have 2 to the power of 18 times 1, which is simply equal to 2 to the power of 18. So now what we're going to want to do is find the value for 2 to the power of 18. So we found out that 2 to the power of 19 minus 2 to the power of 18 is 2 to the power of 18. So now to find the value of 2 to the power of 18, I'm simply going to simplify this a little bit. So 2 to the power of 18, well 18 here, this is the same thing as 9 times 2. And now if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So in this case, this is the same thing as 2 to the power of 9 to the power of 2. Now 2 to the power of 9, what is that? Well, 2 to the power of 5, this is equal to 32. So 2 to the power of 6, this is going to be double of 32, which is 64. 2 to the power of 7 is double of 64, which is 128. 2 to the power of 8 is double of 128, which is 256. And finally, 2 to the power of 9 is going to be double of 256, which is 512. So now I have 512 squared. So now, to solve this, I'm going to rewrite 512 as 500 plus 12 squared. So now I have 500 plus 12 times 500 plus 12. So I'm first going to distribute 500, so I have 500 times 500, which is 250,000, plus 500 times 12, which is going to be 6,000. Now I have this plus 12 times 500, which is 6,000 again, plus 12 times 12, which is 144. Now I'm going to go ahead and add all of these. So I have 250,000 plus 6,000 plus 6,000, which is 12,000. So I have 262,000 plus 144, which is equal to 262,144. So this is my answer.